Okay, so in this video, we're going to take a look again at solving right triangle problems, a little bit more in depth, a little bit more complicated with some of the problems, that's all. So in this particular case, you have a radio dish is on top of a tower. So again, if you can try to imagine something physically in your neighborhood, or maybe look at it online, it's 100 meters above the ground. So there is your tower. So I've got a radio dish, maybe not the exact one we're looking for, but good enough. And it's 100 meters above the ground. So the radar shows that an approaching airplane is 15 kilometers away. Now, this is where things become very difficult for most students to understand, but when it talks about a distance away, and it's talking about the radar detects things in a straight line. So like I got in the picture here, so it's basically measuring the 50 kilometers from the airplane to the actual radar itself. Okay, so that distance there. So that's why I've got the 50 labeled in a diagonal fashion. Okay, the wording might be a little bit different if the distance is a horizontal. It might indicate horizontal distance from the radar dish to the plane. Okay, so that's where you have to be very careful with the language. But it also indicates along a 20-degree angle of elevation. So that is another clue that, yes, the measurement of 50 is definitely on the diagonal here. So again, angle of elevation, start with a horizontal and then elevate up to create the angle that you're looking for, in this case 20 degrees out of the bottom. All right, so you're asked to find the airplane's altitude, which is a fancy way of saying height, and ground distance from the tower. All right, so it's essentially the same sort of idea. Now, see this big blue line here? That is the measurement you're asked to find. All right, the plane's altitude and ground distance from the tower. So the ground distance from the tower is this little g labeled, and the altitude is this height measurement. Okay, this tall one right there. Okay, so you do have a little right angle triangle, but you got to be careful here in terms of how you map this out, because this is where the 20 degrees is. So you need to focus on the triangle that you're dealing with. So this one right in here, that's the one you're going to be dealing with. Okay, so you have to be very aware of that to make sure that you're calculating and doing the right things. Now also, this measurement is in kilometers, but the measurement in the question for the height above the ground of the tower was in meters. So it's not a bad idea to change them so they're exactly the same. In this case, I've decided to change the 100 meters to kilometers. Now what that's going to do for us is it's going to allow me to say, well, this little measurement here, I'll just draw a little arrow to kind of indicate that. So from here to here, oops, is supposed to be 0.1 kilometers. And that distance there. Now, if I have to find this entire blue line, this will be part of that distance. So if I can find the measurement that's right in here, then I can take this number, whatever that turns out to be, and add it to the 0.1, and then I'll get my overall height from the ground. Okay. So the question is, how do you get this number? Well, if you take a look at the measurements that are given here, you have a 20-degree angle and you have the hypotenuse. As far as this reference angle is concerned, you need to find this side here in the triangle, that one there, which is opposite the 20. You have the hypotenuse in this triangle, which is the 50. So opposite and hypotenuse, OH. So that would lead to, if you have O and H, the letter that comes in front, remember the acronym, SOHCAHTOA. Okay, so that's where you're going to be getting, that's where you're going to be getting some helpful information there in terms of what trig ratio to use. So you can use your sine ratio to set up a formula to find that little question mark there, that distance. And then the cosine ratio can also be used to find the ground one. So your cosine ratio, just going to get rid of some of these things in here so you can actually see it. I'm not sure why these have all become locked up, but anyway, so as you can see, the black dotted lines, that is your adjacent and your hypotenuse. That is an easy way of finding the ground measurement. Okay, so the ground distance from the tower, so that's the G. So that is one way you can start off by simply getting the ground distance using your cosine ratio, and then your sine ratio, again, this little portion up here, you can refer to that as x, do a lowercase, and then to solve for x, it would be the sine of 20 degrees is x over 50, and then simply get your result from there. But don't forget the height, or the altitude of the plane, is that answer x, that measurement there, plus the 0.1 kilometers. Now, you could easily add the 0.1 to the 17.1 and get 17.2, or you may find solutions in the back of the book. Use meter, change it to meters. That's why I've just showed you how to do that here as well. Either way, it doesn't really matter. Okay, so the key thing with all these problems is to come up with a diagram, use a 90 degree or right angle triangle to help solve. Similarly for this one here, hopefully it's a little bit easier. So you have a person before rock climbing, so a person's going to scale this big cliff. They need to determine the length of the rope that they need, which is going to be the same as the height of the cliff. At least you can make that assumption. So this person, she paces off 100 meters from the base of the cliff. So again, 100 meters pacing off basically means standing here, walking away from the cliff. So it paces off 150 meters from the base of the cliff and sights to the top of the cliff with a clinometer. Now, a clinometer is a fancy instrument that allows you to measure angle of elevation. So the language angle of elevation isn't in this question at all, but you have to assume that based on the language that you're given. So sights to the top of the cliff, 70 degrees. So the person who is standing here, now obviously you might think, well, the person's not on the ground. We're going to pretend. And there's the angle of 70 degrees all the way up to the top. And you can see you have a nice little right angle triangle. You have to find this height. So again, reference angle 70 degrees. You have the opposite side you need to find. This is the hypotenuse. You don't have that measurement, but you do have the adjacent side. So opposite and adjacent. Opposite and adjacent. Well, you have the adjacent side, but you don't have the hypotenuse. Can't use cosine. Opposite side is what you're trying to find. So you can't use sine. So tangent ratio is the one that's going to help us out here. So the tangent of 70 degrees, so again, you have to make sure you have the proper ratio, the reference angle, and then equals opposite side divided by adjacent. So the opposite side I've labeled with an H, and then divided by your adjacent side, which is 150. After that, same math you've done before, inverse operations, calculator work, and solve. Okay, so this next question, very similar to the first one actually, and again, a little bit more complex. You got a little diagram here. You're trying to find the width of the river. So you can see that's the W that I've labeled here in the diagram. You're talking about a transit. Now, transit is a fancy way of saying tripod, which is where an instrument would sit up at the top where people can measure certain distances and whatnot. You might see them around city streets when they're in construction sites. They have these little tripods and people are looking through them. That's what a transit is. So it's 1.2 meters above the ground. That's the tripod height. And the assistant is standing on the other side of the river holding a 3-meter pole. Now you don't actually see the person, but this is the pole right there. But you don't see the person standing there holding it in the diagram. All right. So you're asked, or you're told, the angle of elevation from the transit to the top of the pole is about 8.5 degrees. Sorry, this was the pole here. So that's the pole. So the 8.5 angle of elevation, again, you need a horizontal and then measure up and right there. So that's why that measurement is 8.5 degrees. How wide is the river? So you have to find the W. Now, to find the W, you only have the angle. You need at least one side in this right angle triangle that you have right here. That triangle right there, you need one of the side lengths. Doesn't matter which one, but you have to find the W and you have the angle. So this green shaded portion that you'll see as this thing fades out, the calculation is 3 take away 1.2. Now why? Well, the pole is 3 meters tall. The tripod is only 1.2 meters tall, so I can get the remaining part here just by subtracting. Okay, and that's important to get that measurement because then I can use that opposite side And I'm looking to find the adjacent side. So opposite and adjacent is tangent ratio, right? Okay. So this diagram that you see down below over here, this is probably the more typical diagram that I would expect students to be drawing out. And it is a little scribble. It doesn't have to be a fancy thing like I've got here, as I've got some images in here. Okay. So try to piece together the information you're looking for. It doesn't have to be that accurate as long as it's labeled accurately. And you maybe got some variables in there that'll make some sense to you. And then you piece together a trig ratio that's going to help you find any missing piece of information. And then, much like you've done before, we've seen in other examples, use inverse operations and all the correct algebra to get the answer that you're looking for, which was the W in terms of the width of the river. And so the river is 12.04 meters. Actually, just to add that in, oops, because you were looking for the width. Okay, so the river is 12.04 meters wide. Okay, another question, very similar to the, as you can see, you've got diagrams set up and there's a couple of right angle triangles already built in. Here, the language is angle of elevation and angle of depression is in the language. Here, you got to be very careful though. So the angle of elevation from the top of a 120 meter building to the top of another second building is 47 degrees. So if you have to elevate to go from one building to another, well, if I was starting here and I wanted to look to the top of this building and do that by looking up, that's impossible. So it makes more sense that you'd be standing here looking up to the top of this building. So that's why this angle of elevation, 47 degrees, really applies to this situation here. So you have a horizontal line, and then you look up to the other building, and there's your angle of elevation in there. Okay? And then in a very similar fashion, the angle of depression to the bottom of the second building, again, is referred to as the second building. So depression down there. So you've got your two measurements. You got the 47 and the 36. So actually now you have two right angle triangles, one up at the top and one down at the bottom. Okay. What else do you know? Well, the smaller building is 120 meters. Now, again, you don't have to draw a fancy diagram. You can just draw some, sticks, or you can draw whatever you need to get this done. You're asked to find how tall is the second building. So this is the second building that the question is referring to. This one right here. Okay, so you're asked to find the height of that building. So these two right angle triangles, they can help because you can find this little piece if you got enough information. And in the other right angle triangle, you can find this little piece. And by adding those pieces together, you'll get the height of the building. So a tangent ratio can be used to find some information that you need. Now you might say, well, why a tangent ratio? Well, you got to keep in mind the only thing that you're given here is this 120 meters. Now that can be translated right there. So you've got a little bit more information as far as the lower triangle is concerned. So if you can get some information that fills in this portion, then you can get some helpful information for the upper triangle. But so sometimes it's like a puzzle piece. You have to find one puzzle piece and then connect it to another puzzle and then get it to work. So why tangent? Well, because the 120 is opposite that angle of 36, and you're trying to find what's been labeled here as capital A, that measurement right there. Okay, now that won't help necessarily get the height, but I already have this portion of the height, it's 120. Okay, so I need to find this upper height portion in the triangle. So that I need that capital A. Once you get that capital A value, doing a little bit of inverse operation, you get about 165.2 just for this measurement there. Then I can use the opposite side, which I can call X. So this top piece there, and the A, which is the adjacent side. So it's another tangent ratio, okay, to find X. And I'm just going to fix something here. This really shouldn't be here. Let me just get rid of this, sorry. Okay, so there's the tangent ratio for the upper triangle. All right, so you have the little dotted line pointing to the X, and then A is the, which we calculated as the adjacent. go ahead and continue the rest of it. So now we have the x, which is the upper part, and we have the lower part, which is 120. So the height has to be 120 plus the 177.2. So the total is 297.2. Okay, last problem. Now this one is a little weird in terms of the language. So if you have difficulty with these ones, I wouldn't worry about them too much. It is very much a language issue sometimes with many of these questions. So a group of students are on an outdoor education trip. They leave their campsite and travel 240 meters before reaching their first orienteering point. Now the problem is you don't know, are they going this way? Are they going that way? Are they going that way? You don't know. All you do know is that after the 240 meters, they turn, creating a 40-degree angle with their previous path. So let's see this. So they have here. So let's say they walk down this way. And that's 240 meters. Then they turn on a different path, and the angle between them, 40 degrees. That's what that's saying. And then travel another 180, and then shortest path back. So just to take a look at how that could look. All right, let's try to add a few things here. So again, here's the campsite. So they travel 240 meters. Now why draw it on a diagonal? Doesn't really have to be, but it's just for convenience. 40 degrees, that's when they turn, they travel another 180. Now the language of the question says they travel the shortest possible path back to the campsite. Now, anytime you hear those words put together, shortest possible path from one point to another. I think you would agree that if you're here, you wouldn't take this kind of a route to get back to the campsite. That wouldn't be the shortest. Neither would something like that. That wouldn't be shortest either. So you go straight back to the campsite. And generally that creates a 90-degree angle from the other path that you were on. Okay, so it's a lot of little kind of guesswork in some regards, and I know that can be kind of confusing at times, but you really have to just fight through some of the language of the question. The question's asking, what is the area of the woods that they cover? So they started here, traveled there, came back here, and then back to the campsite. This is the area you're looking for, so it's the area of a triangle. Base times height divided by 2 is your formula, so it would make sense to refer to the 180 as the base. There's your 90, so that has to be the height, must be the height. And where's the 150 coming, or 151? Well, guess what's going to help you get the height? Trigonometry. So the angle here, the 40 is opposite the height, the 180 is the adjacent. There's your tangent ratio. So the tangent of the reference angle 40 is the opposite side divided by the adjacent. You can use that to get the height. Substitute that into your area formula, and you get the height. And that would be the shortest path. Okay. Now, in a weird way, oftentimes you'll see some solutions give you a different diagram. Now, why would they do this? Very good question. Partly because you can't automatically assume sometimes that the distance of 180 and 240 is going to create a perfect right triangle like in the previous situation up here. You just can't assume that. Okay, there's lots of mathematics that goes into proving that. So the other thought is that, well, they do travel the 180, but if you cannot assume it's 90 degrees, then you don't. So now you have a triangle that is not right angled. Doesn't mean you can't find the area, because the 180 is still the base. The height is now on the inside of the triangle. And you can still determine some information here, but you just can't use the 180 to get that h anymore. You have to use the reference angle of 40. H here of the triangle is the opposite side, but you need to use the 240 to get the h, which in this particular instance, here's your right angle triangle would be the hypotenuse. So sine ratio of the reference angle 40, opposite side, which is the h, and then divided by the 240. Okay, so you have to have a right angle triangle when you're dealing with trigonometry, so you create that in here, and then you get your result. And there you go. Now I've indicated this is not necessarily the shortest path because again, you kind of have to assume one thing or the other. I'm going to tell you mathematically, this is better. This is much better in terms of math because there is no need to prove that this does produce a perfect right angle triangle. Okay. Besides, the h didn't have to be determined using a tangent ratio. If you assume it's 90 degrees, you could just use Pythagorean theorem. Okay, which is in a way kind of a cheat and might not work the way it's supposed to. So that's why you got to be careful with some of these word problems, but try as many as you can and see how many you can get through to get through some of these difficult situations.